All right, a belt runs a pulley of radius 5 inches at 120 revolutions per minute. Find the angular speed of the pulley in radians per second. Angular speed. So the only formula we have for angular speed is that omega is equal to theta over t. All right. So what's the angle? So we know that 120 revolutions. That's our angle. That's going to tell us that's going to be the computation for the angle, because one revolution is equivalent to 360 or 2 pi. We should radians, right? So one revolution is going to be 2 pi, right? Therefore, 120 revolutions is 120 times that. So 240 pi. So now, you see how we get omega? So theta is 240 pi. 240 pi. What was the time for that angle? How long did it take to get to that angle? A minute. So we got to put 1 minute or 60 seconds, right? Because we might as well do that conversion right away. So 60 seconds, that was 1 minute, right? And then I'll just reduce that. So reducing, that's what? 4 pi? Radians, and we'll put the units in there, radians per second. Does that make sense? So that would be the angular speed. Find the linear speed. So how do we find the linear speed? What do you think? S over T or R theta over T, or, let's see, 3 choices. V is S over T, V is R theta over T, or V equals R omega. R omega. I would use R, because we just found omega right in the last part, and we were given the radius. So that's what I would use. I would probably use this one. So V then would be, R is 5 inches. Multiply that by 4 pi radians per second. And then remember, radians is just a pure number, so it takes on the units of the other quantity. So that's going to be 20 pi inches per second. And then we can round that, I guess. Let's see, that becomes 20 pi. 62. If I'm going to go to 1 sig fig like the other measurement, that's going to be 60 inches per second. So just going to 1 sig fig, approximately 60 inches per second.